Good day, everyone. So, for today, our topic is about introduction to rational equations, functions, and inequalities. So, this is the objective. So, distinguishes rational function, rational equation, and rational inequality. So, these are the definition of terms. So, the first one is rational equation. So, it's an equation involving rational expression. So we have an example, x squared plus 6x plus 8 over x plus 4 is equal to 1 over 5. So basically, rational equation is just an equation. So the symbol you need to identify is the equal sign. Okay. So we have another one, the rational inequality, an inequality involving rational expressions. So the same example, we have x squared plus 6x plus 8 over x plus 4 is greater than 1/5. So a rational equation becomes a rational inequality when the symbol, in the inequality symbols is or are present. Next, we have the rational function. A function, basically a function of the form f of x is equal to p of x over q of x, where p of x and q of x are polynomial functions and q of x is not the zero function. So we have f of x is equal to x squared plus 6x plus 8 over x plus 4. So you have a clue when you have an f of x. So basically you are dealing with rational function. So rational function is determined by p of x and q of x, where p of x and q of x are polynomials. Just like, for example, here we have a polynomial x squared plus 6x plus 8, and then we have a polynomial x plus 4. A given equation or a given function is not a rational function when the q of x, meaning to say the denominator, is equal to 0. Because when you divide the number to 0, that will give you undefined, okay, or an extraneous function or equation. Okay, so let's move on to solving rational equations and inequalities. So basically, the definition of terms you need to be familiar with are rational equation, rational inequality, and rational function. So for this topic, we are going to solve rational equations and inequalities. So for the objective, we have solve rational equations and inequalities. So let's have a review. Okay, so before we proceed to solving rational equations and inequalities, so we need to review the prerequisite knowledge or skills in order for us to perform the objective stated a while ago. So here we do have rational expressions and rational equations, okay? We are going to solve numbers 1, 2, and 3 first. So for number 1, you are asked to simplify x minus 2 over x squared minus 4. So when we say simplify, we uh, we get the simplest form of this given rational expression. Okay? So this is a rational expression because, as you can notice, there is no equal sign or there is no equal symbol. So in order for us to simplify this, x minus 2, since x minus 2 is already in its simplest form, so we are going to write it down as is x minus 2 all over. So as you can notice, the denominator, we can simplify it further. Since x squared minus 4 is a special product, so we can factor it out using the sum and difference of two squares. So we are going to write down to parentheses. So plus, then minus, and then get the square root of x squared. The square root of x squared is x. Okay. And then the square root of 4 is 2. So we have positive 2 and then negative 2. Okay, and then after that, cancel out common terms. So we have x minus 2 and x minus 2 as common terms. So that will give you 1 over x plus 2. Okay, class, remember that when we are simplifying rational expressions, we need to apply the different processes or different techniques in factoring. Okay, so let's have example number 2, which is evaluate 3x plus 1 over x squared minus 1 times x plus 1 over 3x squared plus x. Okay, so basically, we are going to multiply this one. So before we multiply, we need to simplify first each rational expression. So here, as you can notice, 3x plus 1 is already in its simplest form. So we are just going to write down 3x plus 1 all over. So as you can notice, the denominator x squared minus 1 can be factored out using the sum and difference of two squares. So we are going to write down again two parentheses and then plus, then minus, and then get the square root of x squared, that is x, and then get the square root of 1, that is 1 and 1. Then multiply by x plus 1, since x plus 1 is already on its simplest form, all over. So as you can notice, the denominator 3x squared plus x can be simplified further using the common monomial factoring. Okay, so basically the common factor for 3x squared and positive x is x. So we are going to bring that out, and then x, then 3x squared divided by x, which is the common factor. So that will give you 3x, and then x divided by x, that will give you 1. Okay, and then before we multiply, we can cancel out common terms. We can cancel out numerator to denominator only. Numerator to numerator is not allowed. So basically, we can cancel out x plus 1 and x plus 1 here. We can also cancel out 3x plus 1 and 3x plus 1. So basically, we have 1 here, no, on the numerator. So we have 1 all over. And then the remaining terms are quantity x minus 1 and then the quantity x. And then we multiply or we evaluate it. So 1 over x squared minus x will be our final answer. Okay, so for example number 3, we have 3 plus x over x minus 2 is equal to 6 over x minus 2. So this example number 3 is a rational equation. So I will show you how to solve rational equations. So we do have three terms. We have 3x over x minus 2 and 6 over x minus 2. So what you need to do is to identify the LCD of these three terms. Basically, the LCD or the least common denominator of these three terms is x minus 2. So what are we going to do with the LCD? We are going to multiply the LCD to both sides of the equation. So I will show you, since x minus 2 is our LCD, so we are going to take x minus 2 times the quantity 3 plus x over x minus 2 is equal to 6 over x minus 2 multiplied by the LCD x minus 2. Okay? And then we just multiply. So basically, x minus 2 times the quantity 3, that will give you 3x minus 6, and then plus. So basically, since it is the numerator, we can cancel out x minus 2. So we are going to have x is equal to, and then x minus 2 times 6, that will give you, we can cancel it out. So we have 6. And then collect like terms. When we say collect like terms, we move all the terms with variables on the left side, and then we move all the numerical values or the constant to the right side. So since 3x and x is already on the left side, so we're just going to copy it. So 3x plus x is equal to, just copy 6, and then we transpose -6 to the other side. When we transpose, we get the opposite sign of the given constant. So since it's negative, it will become +6. So we evaluate both sides, 3x plus x, that will give you 4x, is equal to 6 plus 6, that will give you 12. Then divide both sides by 4. Then that will give you the value. So x is equal to 3. Okay? Okay, so now we move to example number 4 and example number 5. So example number 4 and number 5 are operations on rational expressions, specifically addition and subtraction. Okay, so we have evaluate 5x minus 1 over x minus 8 plus 3x plus 4 over x minus 8. So as you can notice, try to notice the denominators. So they are similar. So we can conclude that the two terms are similar rational expressions. So it's just like when we are dealing with fractions. If the fractions are similar fractions, we just copy the denominator and then add the numerator. Okay, so the same process will be applied here for number 4. So we are going to have just copy x minus 8. So that will give you x minus 8. And then copy 5x minus 1 and then plus 3x plus 4. Okay? And then we evaluate, collect like terms. So we are going to do 5x plus 3x minus 1 plus 4 all over x minus 8. Okay? Is equal to 5x plus 3x, that will give you 8x, then -1 plus 4, that will give you +3 all over x minus. Okay, for example number 5, evaluate 6 over x squared minus 4 minus 2 over x squared minus 5x plus 6. So we can evaluate this two dissimilar rational expressions by getting their LCD in order for us to transform these two rational expressions into similar rational expressions. So before we do that, we need to we need to make sure that everything, the numerator and the denominator is on its simplest form. So as you can notice here, both the denominators are not on its simplest form. Okay, so we need to simplify it first. So we are going to have, so just copy 6 all over. So x squared minus 4 can be factored out. So that will give you x plus 2 times the quantity x minus 2 minus, just copy 2 again, 2 all over x squared minus 5x plus 6. So it is a perfect square trinomial or factoring quadratic trinomial. So we are going to do is to factor it out. So what will be the factor? So x and x. So think of integers that will give you, when you multiply, that will give you the last term, the value of the last term. And then when you add, will give you the value of the second term. So we have, that's -3 and -2. So let's check. -3 times -2 is equal to positive 6. And then when we add these two integers, negative 3 plus negative 2, that will give you negative 5. Okay? So then, after that, we are going to identify the LCD. Okay? So the LCD are the common denominators or the least common factors. So for this one, the LCD is x plus 2, x minus 2, and x minus 3. Okay, so as you can notice, we have 2x minus 2 here. So if we have two common terms, just write one. Okay, just write one term only. So we have minus, again, the LCD is x plus 2 times the quantity x minus 2 times the quantity x minus 3. And then let's do the process. So the LCD divided by the denominator of the first rational expression. So that will give you, so we can cancel it out na, no? So the remaining term is x minus 3. So 6 times the quantity x minus 3. And then the same process goes here. LCD divided by the denominator of the second rational expression. So we can cancel them out. That will give you 2 times the quantity x plus 2 is equal to, so we evaluate 6x minus 18 all over x plus 2, x minus 2, x minus 3 minus x plus 2 times the quantity x minus 2 times the quantity x minus 3. So that will give you 2x plus 4. And then collect like terms, or we can evaluate them already. So we are just going to write down the LCD, which is x plus 2 times the quantity x minus 2 times the quantity x minus 3. Okay. And then write down 6x minus 18. So again, since this is subtraction, we need to distribute this one first. So that will give you negative 2x and then negative 4. It's equal to 6x minus 2x. That will give you 4x. Then negative 18 minus 4, that will give you negative 22 all over x plus 2 times the quantity x minus 2 times the quantity x minus 3. Okay? Okay, so let's proceed to solving rational equations. So let's have an example. Example number 1. So let's have x minus 3 all over x squared minus 25 plus 1 over x plus 5 is equal to 1 over x minus 5. Okay, so this one is a rational equation because we have rational expressions and then we have the equal symbol or the equal sign. Okay, so how are we going to solve this? So again, make sure that the rational expressions is on its simplest form. Okay, so 1 over x minus 5 is already on its simplest form, while 1 over x plus 5 is already on its simplest form. But this rational expression is not on its simplest form. X minus 3, yes, is on its simplest form, but the denominator x squared minus 25, we can simplify it further. So we have, so let's simplify that. So x minus 3 all over x plus 5 times the quantity x minus 5 plus 1 over x plus 5 is equal to 1 over x minus 5. Okay? Then after that, since they're already in its simplest form, we need to identify the LCD. So the LCD for this given is x plus 5 and x minus 5. So as you can notice, we have two terms, x plus 5 and x plus 5. So you just need to write down one x plus 5, and then we have again x 2x minus 5. So we have one here and then another one here. So just copy one x minus 5. So the LCD, so we are going to write it down. The LCD is x plus 5 and x minus 5. So what we are going to do with the LCD is to multiply them to both sides of the equation. So we are going to multiply x plus 5 times the quantity x minus 5 to, so we are going to multiply it. So x plus 5 times the quantity x minus 5, so x minus 3 plus 1 over x plus 5 is equal to 1 over x minus 5 multiplied by x plus 5 times the quantity x minus 5. Okay? So let's distribute. So x plus 5, the LCD multiplied to the first rational expression. So we can cancel out x plus 5 and x minus 5. That will leave you x minus 3. And then LCD, the LCD multiplied to 1 over x plus 5. So we can cancel out x plus 5 and x plus 5. So the remaining term will give you plus. So we are not going to write down 1 anymore. It is understood. So x minus 5 is equal to. So we need to multiply LCD to 1 over x minus 5. So we can cancel out x minus 5 and x minus 5 there. Okay. So the remaining term is the quantity x plus 5. Okay. Now we are going to transpose the terms. So all terms with variables will be put on the left side, while all the constant will be put on the right side. So x, so just copy x since it's already on the left side. Copy positive x since it's already on the left side. So as you can notice here, the the x here is on the right side, so we're going to transpose it. So when we transpose positive x, we get the opposite sign. So since it's positive, it will become negative. It's equal to, since we have 5 already on the right side, just copy. So as you can notice, we have negative 5 here. So we need to transpose it on the other side. That will give you positive 5. So negative 3, we need to transpose. That will give you positive 3. So let's evaluate. So x plus x is 2x minus x will give you x is equal to, so 5 plus 5, 10 plus 3 is 13. Okay. Let's have example number 2. So we have 2 over x squared minus 1, then minus 1 over x minus 1 is equal to 1 over 2. So again, the first step is to make the rational expressions, or the rational terms, into its simplest form. Okay, so this one, we can simplify this. So we're going to write down 2 over x plus 1 times the quantity x minus 1 minus 1 over x minus 1 is equal to 1 over 2. Okay, and then identify the LCD. So what will be the LCD for this one? The LCD will be x plus 1, x minus 1, and then 2. So LCD is x plus 1 times the quantity x minus 1 times the constant 2. And then we are going to multiply the LCD to the both sides of the equation. So we have x plus 1 times the quantity x minus 1 times 2. Then 2 over x plus 1 times the quantity x minus 1 minus 1 over x minus 1 is equal to 1 over 2 times the quantity x plus 1 times x minus 1 times 2. So again, LCD times 2 over x plus 1 times the quantity x minus 1. So we can cancel out x plus 1 and x minus 1 here. So the remaining terms will be 2 times 2 minus. So distribute, again, multiply LCD to negative 1 over x minus 1. So we can cancel out x minus 1 and x minus 1 here. That will give you the quantity x plus 1 and then times 2 is equal to. So here we can cancel out 2 and 2. So the remaining terms are x plus 1 and x minus 1. Okay, and then we evaluate them. So 2 times 2 is 4. Then minus. So the quantity 2x plus 2 is equal to, this will give you x squared minus 1. Okay, and then we distribute the negative sign. So that will give you 4 minus 2x minus 2 is equal to x squared minus 1. So here, we are going to collect again. We are going to collect. So we are going to transpose every terms with variables on the left side and then the constant on the right side. So here, we're going to transpose x squared. That will give you negative x squared minus 2x is equal to negative 1 plus 2 minus 4. So negative x squared minus 2x is equal to negative 1 plus 2. That will give you positive 1. Then 1 minus 4. That will give you negative 3. Okay. And then, since we cannot solve for the value of x alone, so as you can notice, we have an x squared here. So we have a clue that we are going to use or transform this into quadratic equation. So in order for us to transpose this into quadratic equation, we need to transpose negative 3 on the other side. Okay, so that will give you negative x squared minus 2x plus 3. And then equate them to 0. Okay, so in order for us to factor it out, we need to multiply both sides by negative 1. So x squared plus 2x minus 3 is equal to 0. And then since it's a quadratic trinomial, so we are going to factor it out. The same process, think of integers that when you multiply, the answer is negative 3, and then when you add is positive 2. So that is positive 3 and negative 1. And then just copy x, and the x is equal to 0. And then equate them to 0. So x plus 3 is equal to 0. And then x minus 1 is equal to 0. So transpose. So x is equal to negative 3. And x is equal to positive 1. Okay, so that's all for today. If you have questions and clarifications, please do ask. So thank you and God bless.